In this video, we're going to look at the second half of the midterm exam review, version A. So let's start with 14 here. It's another square root equation, and I need to isolate the square root. So I'm going to subtract x from both sides. When I subtract x from 2, they're not like terms, so can't do much better than just 2 minus x. Next, I'm going to square both sides. So we do to get rid of a square root. When you square a square root, poof, it disappears. So we're just left with x plus 18. On the right, we do need to FOIL. When you square a binomial, we write it twice in FOIL. So on the left, I'm going to keep x plus 18. On the right, 2 times 2 is 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x. Negative x times negative x is positive x squared. I do have some like terms that I can combine. So this negative 2x and this other negative 2x are going to become a negative 4x. And I'm going to rearrange the terms here so that the exponents are in descending order. So I'm going to go ahead and put this x squared first. It is a positive x squared, so I'm going to make it positive x squared up front. I'm going to keep the negative 4x in the middle, but this positive 4 here, I'm going to move it to the back. So if I rearrange my terms on the right-hand side, I have x squared minus 4x plus 4. That's how we typically see trinomials written. So I have a quadratic equation, and in order to solve it, I do want to zero. I'm going to move this all the way, so let me just go ahead and copy what I have down here. I want to zero on one side, and I'm going to choose to move over the x plus 18. I don't want a negative x squared. If I try to get a 0 on the right-hand side, I'd end up with a negative x squared, which would be kind of tough to factor. So I'm going to subtract x from both sides. I didn't put it under its like term. So subtract x from both sides. So that'll get rid of that. I'm going to subtract 18 from both sides as well. So that'll get rid of that. So we will have a 0 on the left. The right side becomes x squared minus 5x minus 14. It does factor. Whenever our leading coefficient is a 1, we can look for two numbers that, in this case, add to negative 5 and multiply to negative 14. Those two numbers would be negative 7 and positive 2. So my factors become x minus 7 and x plus 2. And then if I set each of those factors equal to 0 and solve, I've got my two potential solutions. So x might be 7 or x might be negative 2. Now I say potential solutions because we do have the possibility of getting extraneous solutions when we're solving radical equations with an even index. And we're going to find that negative 2 works, but 7 does not work. So I'm doing that in my head, but let me show you why 7 does not work. Let's do a check with 7. So I'm going to take the original equation and plug 7 in for x. And we're going to see why this will not be a solution. So underneath the square root, I get 25. And the square root of 25 is 5. And I'm left with 5 plus 7 equals 2. That's not true. 5 plus 7 does not equal 2. So that's why 7 is extraneous. If you did the same thing and checked with negative 2, you would find out that it does work. It's okay. All right, let's see here. Number 15. Sorry, I'm kind of creeping down into number 15 here. Number 15, they do tell us it's a quadratic type equation, so that's kind of a little hint there that this is, sometimes I heard another instructor call these quadratics in disguise because they're not quadratics, but we can use substitution to make them quadratic. So to get it into a form of a quadratic equation, I want the first term to be, something squared. Typically, we're going to use u. That's just kind of in math, a substitution variable. So if I could make this look like u squared plus 5u plus 6 equals 0, that would be awesome because that's a quadratic equation there. And we can do that. So notice that what I picked for u is x to the 1/5. So I'm letting u be x to the 1/5 power. And then I picked for u squared, I picked x to the 2/5. But let's see, I guess I say I picked it, but it does follow that if I let u be x to the 1/5, and then I square both sides, so let me show, so I'm going to square both sides. So if I square this side, and if I square this side, then it is true that u squared would be x to the 2/5, because power to a power, we multiply those exponents. 1/5 times 2 is 2/5. So that's good. So if I define u to be x to the 1/5, then I will be able to correctly, or it is an equivalent substitution then to make u squared, to put it in place of the x to the 2/5. Now that is always going to happen. Otherwise, we can't call the quadratic type equation. Otherwise, it's, if I define this to be u and then this ends up being u to the 3rd, then that's not going to work. So if it says it's a quadratic type equation, it means that using substitution will transform it into a quadratic equation. So now that I have a quadratic equation, it's really fast to factor. I can look for two numbers that add to 5 and multiply to 6, since my leading coefficient is a 1. And so those numbers would be 2 and 3. So that makes my factors u plus 2 and u plus 3. And so this means that u equals -2 or u equals -3. So I'm just setting those factors equal to 0 and solving. Now this is wonderful, u equals -2 or u equals -3, but our original equation had the variable x. So we don't want to know what u equals, we want to know what does x equal. So this is where we have to back substitute. So I go back over here and I look at what I let u be at the very beginning of the problem. And I defined u to be x to the 1/5. So I'm going to back substitute and replace x to the 1/5 for u. And then some of you might really quickly be able to see how to finish this, because we do want to solve for x. We don't want to solve for x to the 1/5. But if it's kind of hard to see, it might help to put it into radical form. A 1/5 power is the same thing as a 5th root. So if I change these into 5th roots, I feel like it's then easier to see that to solve for x, we're going to need to raise both sides to the 5th power. So that's how I'm going to finish this. So if I raise both sides to the 5th power, taking a 5th root and raising it to the 5th power is going to undo that root there. And so our two solutions are that x could be -2 to the 5th, which is -32. So -32 is one of our solutions. Or -3 to the 5th, which is -243. So those are the two solutions. We do have the potential of extraneous solutions with these equations that contain rational exponents. but it's not something that we talk about in this course, or that we see in this course, I guess. All right, number 16. I'm going to go ahead and copy this inequality over here. So we have a three-part inequality, and when we have a three-part inequality, we work to isolate x in the middle. Whatever we do to the middle to isolate x, we do to all three parts. So I would want to subtract 7, trying to get x all by itself in the middle. Whatever I do to the middle, I have to do to all three parts. So after subtracting 7, I get negative 20 is less than or equal to 2x, which is less than 4. Again, working to isolate x in the middle, I would divide by 2. And whatever I do to the middle, I got to do to all the two outside parts as well. So we now have negative 10 less than or equal to x, which is less than 2. Now, anytime we have a three-part inequality, it is always between the two numbers. It didn't ask us to graph, but let me go ahead and graph real quick. So this would be all x between negative 10 and 2. Negative 10 is included, but 2 is not. I can tell that by just looking at the inequality symbols. By the negative 10, the symbol is a less than or equal to. By the 2, it's just a less than. So our interval notation would look like this. Now, sometimes it's really difficult for students to see that it is between the two numbers because they see two less than symbols, and they feel like it should be left of both numbers. But looking at the part over here, so like this is where they think it should be left of negative 10 because they see a less than or equal to symbol. But remember that negative 10 is less than or equal to x is equivalent to x is greater than or equal to negative 10 because the mouth is opening towards the x. So it actually is to the right of negative 10, even though you see a less than or equal to symbol. So anytime we see a three-part inequality, it's always, always, always between the two numbers. Okay, 17. Speaking of three-part inequalities, when we see an absolute value inequality with a less than or equal to symbol, we can convert that into a three-part inequality. So I'll just kind of write, like if you have the absolute value of A is less than or equal to B, this is equivalent to negative B is less than or equal to A, which is less than or equal to B. It's pretty easy to see that if you look at just like a really basic absolute value equation, like the absolute value of x is less than or equal to 3. A little bit tougher when you get more complicated absolute value equations. But I can transform this into a three-part inequality. So what you see above is equivalent to this. And then just as I did with the last problem, I am going to work to isolate x in the middle. Whatever I do to the middle, I'm going to start with multiplying by 4 so that I can clear my fraction. Whatever you do to the middle, you got to do to the outsides as well. So I'm going to multiply every part by 4. In the middle, the 4s are going to cancel. So I've got negative 12 is less than or equal to 3 plus 2x, which is less than or equal to 12. And then I'm going to subtract 3, all three parts. In the middle here, that's going to go away. So we have negative 15 is less than or equal to 2x, which is less than or equal to 9. And then divide by 2, all three parts. So we have negative 15 halves is less than or equal to x, which is less than or equal to 9 halves. The interval notation, because it's always, always between whenever you have a three-part inequality. So this would be our interval notation. It's going to be all x between negative 15 halves and 9 halves. Now this one does ask us to graph as well. To graph, you might want to use your calculator. Negative 15 over 2 is equivalent to negative 7.5. So negative 7.5 would be right here. This time I used a solid dot. You could also use a bracket there. They're both correct. 9 over 2 is equivalent to 4.5. So 4.5 would be about right here in between the 4 and the 5. And then I would just shade in between the two. '18, we have another absolute value inequality. First thing I'm going to do is I am going to isolate the bars. We want to isolate the bars. We do not want to distribute. Never distribute over absolute value bars. It does work sometimes, but not all the time, so we don't want to get in the habit. So we have the absolute value of 2x minus 5 is greater than 7. So this time, instead of a less than or equal to symbol, we have a greater than symbol. So if we have the absolute value of some expression A, we'll say is greater than B, then this is equivalent to A is greater than B or A is less than negative B. So this time we're going to set ourselves up not a 3-part inequality, but 2 inequalities separated by an or. And we're going to see that our solution set for this one is going to be 2 non-overlapping intervals. All right, so for this left inequality, we're going to get x is greater than 6. I feel like you could probably do that. Add the 5 divided by 2. This one, we're going to get x is less than negative 1. So I think I might graph first this time. So x is greater than 6 would be this interval right here. X is less than negative 1 would be this interval over here. And so our solution set would be, as I said, 2 non-overlapping intervals. I am going to put a union symbol in the middle. That's what we do, and we have non-overlapping intervals. So this would be our solution set. So, negative infinity is used to represent a really large negative number and infinity a really large positive number. Okay, for 19, 20, and 21, we are going to need sign charts. Sign charts are used whenever we're solving quadratic, cubic, and rational inequalities. For 19, I'm going to factor. I'm going to look for 2 numbers that add to negative 8 and multiply to 15. So those 2 numbers would be negative 5 and negative 3. So my factors are x minus 5, x minus 3. And we're going to find where, for what x this is equal to 0. And those are going to be the numbers at which our inequality is going to change sign from either positive to negative or negative to positive. So I'm going to start, and I'm going to set these equal to 0. I realize this is an inequality, but we start by finding these 2 numbers here. So we have 5 and 3. And I'm going to put them on a number line because I feel like it's helpful to come up with the intervals using a number line. So I put them in numerical order. 3 is smaller than 5. So these 2 numbers split our number line into 3 intervals. Interval 1, interval 2, interval 3. Those 3 intervals go at the top of your chart. So I'm going to make kind of a big chart here. At the top of my chart, my first interval is negative infinity to negative 3. I'm going to use a bracket by the negative 3 because my inequality symbol is a greater than or equal to. Oh, sorry, I don't know why I put negative 3. How about positive 3? Sorry about that. Positive 3. Okay, then my second interval will be from 3 to 5. And my third interval will be from 5 to infinity. Over here in the first column, I'm going to write in my factors. My factors are x minus 5 and x minus 3. And then this is called a sign chart because we just fill in the signs of the numbers within each interval. So I need to pick a number between negative infinity and 3. Don't pick 3 even though 3 is included in that interval. Otherwise, one of your factors will be 0, which is not positive or negative. So you pick a number in here, any number you want. Oftentimes I'll pick negative 100 because it's always in that first interval. I mean, unless you had like a, x plus, 103 as your factor, but typically negative 100 is always going to be in that first interval. So if I pick negative 100 and I plug it into each of the factors, I'm going to get a negative result. If I plug negative 100 into here, I get negative 105, but all I really care about is it's negative. If I plug negative 100 into x minus 3, I get negative 103, but again, all I care is it's negative. And the result would be positive because we're multiplying these two factors together. So if negative 100 is plugged into this, or even this, the non-factored version, it's going to end up with a positive result on that left-hand side of the inequality. Then I'm going to plug a number into the second interval. How about 4? 4 is between 3 and 5. 4 is negative, but then it's positive because 4 minus 5 is negative 1. 4 minus 3 is positive 1. A negative times a positive is a negative. And then I could pick something like 6 over here, or, 100 is fine, whatever you want. 6, when plugged into the two factors, I get positives both times. Positive times a positive is positive. Then it's this interval and this interval that are our solution set, because we want x squared minus 8x plus 15 to be greater than or equal to 0. So we're looking for a positive result because we want it to be greater than or equal to 0. So our solution set then is the first interval, negative infinity to 3, with then the last interval. All right. Number 20 is a rational inequality, but the process is extremely similar to what we just did. I'm going to factor the bottom. It factors into x plus 7 times the quantity x minus 2. This time, we're just going to have a bigger chart. I'm going to find where each of the 3 factors is equal to 0. I only had 2 factors in the last one. But this time, x plus 5 would be 0 when x is negative 5. X plus 7 is 0 when x is negative 7, and x minus 2 would be at 2 is when it becomes 0. So my 3 numbers are negative 5, negative 7, and 2. I always kind of like to put them on a number line because then I feel like I can see the intervals pretty well. I do want to put them in numerical order. So negative 7 is the smallest, followed by negative 5, followed by 2. So I have 4 intervals here. Those 4 intervals are going to go at the top of my chart. I also have 3 factors, and so those are going to go over here. I'm going to have 3 factors. So my intervals are negative infinity to negative 7. This time I'm using parentheses everywhere because my symbol is a greater than symbol, so using parentheses. Negative 5 to 2, and 2 to infinity. So those are my 4 intervals. My factors are x plus 5, x plus 7, x minus 2. All right, so first I pick a number that is between negative infinity and negative 7. Like I said, I often pick negative 100 because it's always, I shouldn't say always in that interval, but, unless we have a really crazy factor of, like I said, x plus 200, negative 100 is going to be in that first interval. So negative 100, when plugged into the 3 factors, it's negative for all of them. 3 negatives make a negative. Now, 2 negatives make a positive. But if you had, a positive and a negative, it's going to be a negative. So an odd number of negatives will have a negative result. Something I show my students is that as long as your factors are all unique and you don't have like x plus 5 quantity squared, that's a different story, then the results will alternate. But again, just be careful, because if you would have, one of these would be squared, that's not the case, so just be careful. But if we've got 3 unique factors, they do alternate, so you can kind of, save a little bit of time there. And again, we're looking for positive, because my symbol is a greater than. We want this quotient here to be greater than 0. So the quotient is greater than 0 in intervals 2 and 4. So our solution set then would be -7 to -5 with 2 to infinity. So the union of those 2 intervals. Okay, 21. So this is our last one that requires a sign chart for this part. Sorry guys, taking a drink real quick. And with inequalities, it doesn't work to cross multiply, so don't try that. We just need to get a 0 on one side. So I'm going to go ahead and take this. Sorry, I was supposed to circle that. And I'm going to move it over to the other side. And when I say move it over, really what I'm doing is I'm subtracting it from both sides. So sorry, that was really messy. So I'm going to subtract 5 over x minus 6 for both sides. So now I have less than or equal to 0. Now it's going to end up being a lot like number 20. But I do need to get a single rational expression on the left-hand side. So to do that and to actually subtract these, I need a common denominator. So I'm going to multiply the first rational expression by x minus 6, top and bottom. Second one by x plus 3. So there's my common denominator. I'm going to choose to not distribute yet. I'm just going to subtract my numerators and retain my common denominator. Then I'll worry about distributing in the next step. All right, now I'm ready to distribute. So I have 4x minus 24 minus 5x minus 15 all over my common denominator. I always wait to distribute because I feel like students make less errors that way. Sometimes if you distribute here and you get 5x plus 15, they forget that you're supposed to subtract the 5x and also subtract the 15. So it is minus 5x minus 15. But anyway, as long as you understand that, doesn't matter when you distribute. So combining like terms, I get negative x minus 39 all over x plus 3 times the quantity x minus 6, and this is less than or equal to 0. Okay, so it does look a lot like number 20 now. I've got a binomial on top and a trinomial on bottom. Well, it's factored into 2 binomials, but it would be a trinomial. So very similar. I need to figure out where these factors equal 0. The bottom, I feel like students can usually do pretty fast. They can see that negative 3 would make this 0, and they see that positive 6 would make that 0. Sometimes it's tough when you have a negative x. I'm going to actually show my work here. This one is going to be a negative 39. So negative 39 equals x would be what's going to make that factor equal to 0. So this one up here is actually a negative 39. That will make that 0. So I'm going to put these on a number line. I just feel like it helps. So negative 39, negative 3, and 6. So negative 39, negative 3, 6. Splits my number line into 4 intervals again. Here's the first, here's the second, here's the third, here's the fourth. Now there is something that occurs with this one that did not occur in number 20, and that is our symbol is a less than or equal to. And typically, when we have a little bar underneath our inequality symbol, typically we always use brackets. But when you have a denominator, like we do here, you cannot use brackets by the numbers that would result in division by 0. So I'll put a B. I am going to use brackets by the negative 39, so B for brackets. Not a problem. Negative 39 makes the numerator 0, but that's okay. But I'm going to use P for parentheses. These numbers must get parentheses, even though our symbol is a less than or equal to. It all has to do with the fact that we do not want to divide by 0. Okay, running out of room, so let me kind of move this down a little bit here. Okay, so I'm ready to make my chart now. So kind of like with the last one, the chart's going to be pretty big. So my first interval is negative infinity to negative 39. Since I put a B by that means brackets, I can use brackets by negative 39. Next interval, negative 39 to negative 3. Bracket by negative 39, parentheses by negative 3. Negative 3 to 6, parentheses, 6 to infinity. My three factors are negative x minus 39, x plus 3, and x minus 6. I'm going to pick a number to plug in. How about negative 100? Like I said, it's always going to be in there. So negative 100. Now, negative 100, when plugged into the first factor, is actually positive because it's a negative 100, which would be a positive 100 minus 39. So that would be positive 61. It will make this one negative, though, and that one negative. Two negatives make a positive, and a positive divided by a positive is positive. And then I am going to cheat here and let them alternate. As long as your three factors are unique, or your factors are unique, they will alternate like that. And this time, I'm looking for the negative results because we want this to be less than or equal to 0. So we're looking for this to be negative. So my final answer then is negative 39 to negative 3. So all of those numbers in that interval satisfy the inequality, as well as the numbers from 6 to infinity, not including 6. Okay. Number 22. I'll move this down here because I feel like I'm going to need a lot of room here with 22. Okay, 22, we're given 2 points, and we're asked to write our answer in point-slope form, slope-intercept form, and general form. Starting with point-slope form. Point-slope form, so I'll just put P-S, point-slope, is y minus y1 equals m times the quantity x minus x1. So I'm going to let this be my x1, y1. I'm going to let this be my x2, y2. Before I'm able to do point slope form, I do need to find m, which is the slope. So m equals y2 minus y1 over x2 minus x1. So I'm going to start there. So we have 5 minus negative 2 over negative 3 minus negative 5. When we subtract a negative, we can add the opposite, so plus, 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 plus. So I'm going to get 7 over 2 as my slope. So I now have m. The formula does use x1 and y1, so I will use the first point. However, you could also use the second point, and it is also correct. We just use x1, y1 in the formula, but whatever you prefer. I'm just going to go ahead and use the first point. So point slope would be y minus negative 2 equals 7 over 2 times the quantity x minus negative 5. This is not incorrect, but you might want to make it look a little nicer. We know subtracting a negative is the same thing as adding the opposite, or plus plus. So I guess the best answer for point slope form would be this right here. So that would be our first answer for point slope form. Okay, slope-intercept form. Sorry, it's kind of hard to see this. I think you can tell that's a 7. Okay. Slope-intercept form, so I'll call it S/I, slope-intercept. It's y equals mx plus b. So all we need to do is take this equation that we've already written and solve for y. If we solve for y, we've got slope-intercept form. So I'm going to first distribute the 7/2. And when I take 7/2 times 5, I just made it 5/1. You can see where, hopefully you can see where I'm getting 35/2. 7 times 5 is 35, 2 times 1 is 2. And then I would subtract the 2. So y equals 7/2x plus 31/2. Now, most of you have nice calculators that can do 35/2 minus 2. To show you what I'm doing it in my head, but I am getting a common denominator. So I multiplied in my head by 2/2. So I just took 35/2 and subtracted 4/2. That's where I got 31/2. When we subtract, we do need a common denominator. We subtract numerators and retain our common denominator. Okay, lastly is general form. General form is ax plus by equals c. Basically, we have x and y on the same side of the equation and the constant all by itself. So with this equation here, y equals 7/2x plus 31/2. I want the x and y to be together. Technically, in proper general form, the x is the first variable, and we try to keep its coefficient positive. So I'm actually going to choose to subtract the y so that I keep the 7/2x first and keep it positive. And then we want this constant by itself. So I'm going to take it over here, and it will be negative because I'm subtracting it. That's how I get it over to the other side as I subtract. So I have negative 31/2 equals 7/2x minus y. Now, the other thing they say about general form is that you're supposed to clear fractions. So I notice I have a couple denominators of 2. So if I multiply both sides of the equation by 2, that's going to clear my fractions. So we have now negative 31 equals 7x minus 2y. Don't forget to take the 2 times the y. Sometimes students will forget that. We do distribute the 2. Lastly, if you want, again, this is not incorrect, but if you want, we could just kind of, it's the symmetric property of equations, and just kind of flip the 2 sides. So instead of the negative 31 being on the left, we can put it on the right instead. So that would be our general form. Um, 23 is just having you apply some formulas. In part A, the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So just having you apply that formula. The first point we'll call x1, y1. The second point we'll call x2, y2, and really just kind of plug and chug. So we're going to have negative 8 plus negative 4 all over 2, and negative 9 plus 3 all over 2. This will give us negative 12/2 and negative 6/2, which reduces to negative 6, negative 3. And that is it. A midpoint is exactly as it sounds. It's really the point right in the middle of the 2 if you were to connect the 2 points with a line segment, this point would be right in the middle. Distance formula. So D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Again, we're just kind of plugging and chugging into the formula. So this one is going to be -4 minus -8 quantity squared plus 3 minus -9 quantity squared, all under that square root there. Minus the negative, plus, 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 plus. So we end up getting the square root of 4 squared plus 12 squared. And this would be the square root of 16 plus 144, which would be the square root of 160. We do want you to simplify the square root. We don't want you to plug it into your calculator and get a decimal. We do want it simplified. So I'll make a factor tree like I did in the last video, if you saw my last video. So let's see, 160, it's 16 times 10. 16 is 4 times 4. 10 is 2 times 5. And you know what? I could keep going, but anytime you have 2 of a kind, you're able to pull that in front. So I could keep going, but why don't I just stop here? I see a pair of 4s. So I could put a 4 in front. And then the 2 and the 5 are not 2 of a kind. And so those are going to stay underneath the square root. So my best answer would be 4 square root 10 then for the distance. All right. Number 24. Almost done here. We got 24, 25, and 26. Okay, so just a couple left. 24. This one is also requires that we use the distance formula. So let me go ahead and write that down again. I know it's right above, but we'll go ahead and write it down one more time. So here's our distance formula. And this time they give us the distance is 4. So over here for D, I'm going to plug in 4. They also give us a point, 3, 2. All right, so we're going to use 3, 2 as a point. We'll call that our x1, y1. We are not given a second point, though. We are supposed to find that second point. We want to find a point that's on the x-axis, and they do give us that distance. So we have the D. The D is known. Now, when I go to write this second point here, if I use x, y, that's not going to be helpful because I'll have 2 unknown variables. I'm going to use the point x, 0. I can do that because they tell me that the point lies on the x-axis. And every point on the x-axis has a y-coordinate of 0. So I can do better than xy. I can do x0. This is going to end up being my x2, y2. So now I'm going to plug in all that I have here, and I'll have an equation with only one unknown, which means I'll be able to solve. So 4 is our D, x minus 3 quantity squared under the square root plus 0 minus 2 quantity squared. So we have 4 equals the square root of x minus 3. Ooh, that's a crazy looking 3. Okay. X minus 3 quantity squared plus 4, because 0 minus 2 is -2, but then when you square, you get 4. And we've seen a couple square root equations in this review already. We know that we can square both sides of an equation, and that when you square a square root, it's gone. So I'm going to choose to square both sides. When you square 4, you get 16. When you square a square root, disappears. You just get what's underneath. Okay, now if you want, you could expand this, but it's actually faster to leave it in factored form. I'm going to use the square root property. So I am going to isolate that squared quantity to get 12 equals x minus 3 quantity squared. I might flip it around. I feel like I like the squared quantity on the left. Okay, so my equation is x minus 3 quantity squared equals 12. So square root property, we use this when we were completing the square in the first video, if you saw that. Basically, you can take the square root of both sides, but it is plus or minus. Square root of x minus 3 quantity squared is just x minus 3 plus or minus 2 square root 3. 12 is 4 times 3, and 4 is 2 times 2. Because you have a pair of 2's, you can bring the 2 in front. 3 stays underneath. And then lastly, I shouldn't say lastly because there's one more step after this. We are going to isolate x. We're going to add 3 to both sides. And as we saw with completing the square, if you watched that part, the 3 typically is seen in front of the plus or minus. That's kind of the proper way to write. So we end up getting 2 x values, which isn't surprising because there would be a point on the x-axis on either side of the point 32 with a distance of 4 from that point. So we get 2 x values. We are supposed to write, the question asks us to write the points, find all points on the x-axis. So what we just found is we just found the x coordinates of those points. The y coordinate of those points is 0 because every point on the x-axis has a y coordinate of 0. So to write them as points, one of my x coordinates would be 3 minus 2 square root 3 with a y coordinate of 0. And the other point would have an x coordinate of 3 plus 2 square root 3 with, again, a y coordinate of 0. So these are the 2 points. So I like my students, I give a point for this problem for actually writing the points. If you just, for my students, if they just say x equals, then I'll take off a point, but I don't know what your instructor will do. Okay, domain. So A and B, they're pretty similar for this problem, but they a little different as well. With domain, each of these are going to have 2 restrictions. We can't divide by 0. So we're going to make sure that the denominator does not equal 0. And we don't want to take the square root of a negative number. So we're going to have x plus 3. We want it to be greater than or equal to 0. It's okay to take the square root of 0. Square root of 0 is 0. The square root of a negative number, we can do it, but it's not a real number. So that's why we're making that restriction that the radicand has to be greater than or equal to 0. So what we're going to do for these is exactly what I just wrote here. You're going to let the denominator, so denominator cannot equal 0, and the radicand, which is what's under the radical or under the square root, has to be greater than or equal to 0. Those are going to be our 2 restrictions here on the domain. To factor x squared minus 9x plus 18, 2 numbers that add to negative 9 multiplied to 18 would be negative 6, negative 3. And then if we set each of those factors equal to 0 and solve, we have that we do not want x to be 6 or 3. So 6 and 3 have to be removed from the domain. They cannot appear in the domain. Over here, we can subtract 3 from both sides. We also have that we only want to plug in numbers greater than or equal to negative 3. So here's how I like to do it. I like to draw a little number line. I feel like it's helpful. And put the numbers. So I've got negative 3, 3, and 6. Because I don't want x to be 6 or 3, I'm going to put an open circle there. I don't want to shade through those. Those cannot be part of my domain. And then I shade in this interval, greater than or equal to negative 3. And that right there is your domain. These are all the numbers that you could substitute or plug in or input into that function, and you would get a real number output. So my domain is negative 3 to 3, 3 to 6, 6 to infinity. So basically it's all real numbers greater than or equal to negative 3 with the exception of 3 and 6. We want to remove those because those would result in division by 0. Okay, part B, I'm going to do the same thing. Denominator cannot equal 0. And the radicand must be greater than or equal to 0. Two numbers that add to -8 multiplied to -20 would be -10 and 2. So we do not want x to be 10 or -2. Over here, subtract your 1. X has to be greater than or equal to -1. Put these all in a number line. -2 is the smallest, then comes -1, then comes 10. Open circles around -2 and 10. I do not want to shade through -2 and 10. They are not in the domain. Now I'm going to shade in or color in this interval. Here's my domain. This -2, we're just going to ignore it. It's out of, I'm just going to write ignore. It's out of this interval, so it's not going to affect the domain. The domain is right here. All numbers greater than or equal to -1 with the exception of 10. So my domain would be -1 to 10, 10 to infinity. So I don't have to worry about removing -2 because it's outside this interval here. So like I said, they're very similar, but a little different because in A, both numbers were inside that interval, where in B, one was outside. Okay, guys, you made it to the end. Congratulations, 26, we can do it. So find and simplify the difference quotient. So first of all, I do want to remind you that f of x plus h does not equal f of x plus f of h. Sometimes students will do that. Okay, don't do that, frowny face. We need to substitute x plus h into the function for x. Okay, so I'm going to kind of have a big fraction here. So f of x plus h would be 3 times x plus h quantity squared plus 6 times the quantity x plus h. Okay, so that's this f of x plus h part. I took x plus h, substituted into the function for x. Okay, also up in the numerator, I'm then supposed to subtract f of x. F of x is the original function. So now I'm going to subtract the original function. I do subtract all terms, which means they're both going to change sign. Minus 3x squared minus 6x. The whole thing is over h. Okay, now we're going to figure out what this craziness is here. When you square x plus h, this is what you get. I've done this so many times, I have it memorized. I don't expect you to memorize it. To square x plus h, you could just write it twice in FOIL. I'll do it over here. You're going to get x squared plus xh plus xh plus h squared. Now, I went ahead and combined like terms here in the middle to get a 2xh. That's where that's coming from. I won't distribute just yet. I'll do that in the next step. Minus 3x squared minus 6x all over h. Okay, so I just expanded x plus h quantity squared. Now I'm going to distribute. So I have 3x squared plus 6xh plus 3h squared plus 6x plus 6h minus 3x squared minus 6x all over h. I have a lot that cancels 4 terms. I have a positive 3x squared and then I have a negative 3x squared, so those are going to cancel. I also have a positive 6x and a negative 6x. So I now have left in the numerator 6xh plus, kind of running out of room here. Let's see. If I do this, it's going to move down everything, isn't it? That's okay. I'm going to move down everything. Okay, sorry guys. I just need a little bit extra room here. Okay, let's try this again on a new line. Okay, so left in the numerator we have 6xh plus 3h squared plus 6h, and all of this is over h. Last thing you're going to do is you can reduce. Every term contains an h. If you can see that without factoring an h out as a GCF, go for it. You don't have to do this, but If you factor out an h from the numerator, noticing it's a GCF, then you can cancel that common factor in the top and bottom. So final answer is 6x plus 3h plus 6. All right, thanks for watching. Good luck on your midterm.